Good morning, good night, good evening, whatever time it is, whichever part of the world you're from. Hi, my name is Tyler Rochester, and today I'll be presenting on the basics of climate change. So, the objectives of this presentation is to explain the greenhouse effect and differentiate between natural and anthropogenic climate change, analyze historical climate data and scientific evidence supporting anthropogenic climate change, and to evaluate the environmental, socio-economic, and geopolitical impacts of climate change. So, before we jump into the meat of the matter, we would like to ask ourselves, what is climate change? So, in order for me to explain this, I'm going to use the assistance of a scenario. Okay, so this is my friend Simon. Simon takes a stroll to school, work, whatever you want to call it, every day at the same time, every morning. So, over time, Simon realizes that the temperature it's a lot hotter and it's a lot more humid. And Simon has realized that this has occurred over the period of 6 months. So, essentially, basically, this means that the climate has changed. In essence, climate change refers to the long term shifts in temperatures and weather patterns. So, when speaking about climate change, there are two specific causes. You have the natural causes and you have the anthropogenic causes. Natural meaning that the earth itself, whatever was developed by, let's God Himself, whatever was developed by the earth gives off greenhouse gases and causes climate change essentially. So, volcanic eruptions, solar variations, changes in the Earth's orbit are all examples of the natural causes of climate change. Anthropogenic causes now is essentially human like causes influenced by human activities. So, whatever is being done by humans is essentially causing the climate to change. So, examples of this would be burning of fossil fuels, deforestation, and the raising of livestock. So, before we go any further, we're going to take a trip to, I would like to call it the Museum of Climate Change. Here is where we're going to discuss some historical data about climate change back in the past, and let's see how it is, what climate change is like compared to today. So, we're going to essentially compare the two, climate change in the past and climate change in the present. This is the past. The Earth was formed about 4.5 billion years ago. It's hard to say exactly what the Earth's daily weather was like in any particular place on any particular day, thousands or millions of years ago. But we know a lot about what the Earth's climate was like way back then because of clues that remain in rocks, ice, trees, corals, and fossils. These clues tell us that the Earth's climate has changed many times before. There have been times when most of the planet was covered in ice, and there have been also much warmer periods. Over at least the last 650,000 years, temperatures and carbon dioxide levels in the atmosphere have increased and decreased in a cyclic pattern. Alright, this image is basically showing the fluctuations in the carbon dioxide concentration over a particular amount of time. The years are there. As you can see, the 400 BC meaning before Christ, and there's another graph below it showing the temperature compared with today. Today's climate is different. So this is going to tell us about the climate today compared to the past. People's activities are the main cause. By burning lots of fossil fuels like coal, oil, and natural gases, people are overloading the atmosphere with carbon dioxide and adding to the greenhouse effect. People are also adding other heat trapping greenhouse gases such as methane and nitrous oxide to the atmosphere. Greenhouse gases are at a record level in the atmosphere. For hundreds of thousands of years, the concentration of carbon dioxide in the atmosphere stayed between 200 and 300 parts per million. Today, it's up to nearly 400 parts per million, and the amount is still rising. Along with other greenhouse gases, this extra carbon dioxide is trapping heat and causing the climate to essentially change. Okay, so this image, it's not coming up. I don't know why, but essentially it's showing the concentration of carbon dioxide in the atmosphere from the period of the 1950s straight to today, essentially 2020. And there's another image or another graph below it showing the temperature worldwide. Okay, so in order for me to explain the greenhouse effect, I'm going to use a greenhouse. And there are different stages there. Basically, how the greenhouse essentially is deemed to be effective. So, first, light enters the greenhouse. The roof and the walls of the greenhouse are made of glass or transparent plastic sheeting, allowing sunlight and sunshine through. Number two, plants and objects absorb light. The plants and other objects inside the greenhouse absorb the light energy. Number three, conversion to heat. The absorbed light is converted to heat by the plants and other objects. Number four, slow release of energy. As the plants and objects release heat, they continuously warm the air around them. And number five, the trapped heat. The heat is trapped inside the greenhouse, creating a warm microclimate suitable for growing plants year round. So basically, this is similar to the greenhouse effect. But in the greenhouse effect, there are specific gases that give off this warming effect. The sunlight emits energy in the form of sunlight. The sun emits energy in the form of sunlight, which reaches our planet. When the light hits the Earth's surface, it warms up. The warmed surface then emits heat energy, infrared radiation, back into the Earth's atmosphere. Certain gases in the atmosphere, such as carbon dioxide, water vapor, methane, and others, act like a greenhouse. They allow sunlight to pass through, but absorb and re emit the heat energy, preventing it from escaping into space. As a result, the Earth's surface and lower atmosphere become warm than they would be without these greenhouse gases. This warming effect is essential for maintaining temperatures suitable for life on our planet. So, this is my image of, well, my illustration of global warming, which essentially is the same thing as the greenhouse effect. So basically, global warming is a gradual increase in the Earth's temperature, generally due to the greenhouse effect caused by increased levels of carbon dioxide, CFCs, and other pollutants. So, this is the causes of anthropogenic climate change. So there's several causes of anthropogenic climate change or climate change influenced by the activities of human beings, but this is just a few. These are just some examples. All right, so the first one is generating power. Generating electricity and heat by burning fossil fuels such as coal and natural gases releases greenhouse gases into the Earth's atmosphere. These gases, notably carbon dioxide and methane, trap heat from the sun, leading to an increase in global temperatures. Number two, manufacturing goods. When producing goods, the manufacturing sector emits carbon dioxide and other greenhouse gases that causes global warming, both by burning fossil fuels through certain industrial processes. Manufacturing accounts for about a quarter of the direct carbon emissions in the US and is one of the largest emitters of greenhouse gases in Europe. The third one and the final one is deforestation. We must all know what deforestation is, the cutting down of trees, the removal of trees. Deforestation refers to the purposeful clearing or thinning of trees and forests. When deforestation occurs, much of the carbon stored by trees is released back into the atmosphere as carbon dioxide, which contributes to climate change. We also lose a crucial ally in keeping excess carbon out of the atmosphere and in slowing global warming. All right, so what this means is that trees essentially use up carbon dioxide. So if the tree was still there, it would be using up the excess carbon dioxide in the air instead of it going to the atmosphere, and the tree would in turn produce oxygen. Greenhouse gases. Greenhouse gases are gases in the atmosphere that raise the surface temperature of plants in of planets, including Earth. What sets them apart is their ability to absorb the wavelengths of radiation emitted by a planet, leading to the greenhouse effect. The five most abundant greenhouse gases on Earth are water vapor. It causes about half of the greenhouse effect but is not directly influenced by human activities. Two, carbon dioxide, responsible for about three quarters of global warming, primarily from burning of fossil fuels. Three, methane, contributes significantly to warming and lasts in the atmosphere for an average of 12 years. Number four, nitrous oxide, a minor greenhouse gas. And number five, ozone, also plays a role in the greenhouse effect. Now, it should be noted that you have good ozone and you have bad ozone. So, the ozone layer is good, but once ozone passes a certain layer in the atmosphere, essentially the troposphere, if it's in the troposphere, it's deemed to be poisonous. It's not supposed to be inhaled by us. Okay, let me rephrase that. It's not good to inhale ozone. It's poisonous. And it might also lead to death. All right, so these are impacts of anthropogenic or the effects of anthropogenic climate change. So this first image is depicting harsh temperatures and drought. All right. So climate change leads to hotter temperatures and worsened droughts through several interconnected mechanisms. Even a small temperature increase makes a significant difference. Heat waves are becoming more common, longer, and more intense. For instance, the Sahel region of Africa experienced extreme heat waves linked to climate change, with temperatures reaching 48 degrees Celsius in Mali. In the UK, temperatures exceeding 40 degrees Celsius occurred for the first time due to climate change. Drying out soil. Heat waves fueled by climate change cause evaporation, reducing surface reducing surface water and drying out soil and vegetation. This leads to more intense heat as the air above warms up more quickly. Increased water demand during hot weather exacerbates water stress. All right, so what this is basically saying is that because the climate has changed, the temperature has increased, it also increases the evaporation rate or the evapotranspiration rate, which means more water is evaporating than is being precipitated, which essentially would lead to a shortage of water and the demand for water would go up. The second impact is it would cause more severe storms. Climate change leads to more evaporation, increasing water vapor in the atmosphere. This extra moisture serves as a fuel for powerful storms. Rising temperatures supercharge the atmosphere, making it more conductive to extreme weather events. For every 1.8 degree degrees Fahrenheit increase in sea surface temperature, extreme storms may rise about 21%. As Earth warms, ocean surface temperatures rise. Warmer oceans provide more energy for storms to develop and strengthen. And the last effect is it causes a lot more health risks. Climate change directly contributes to humanitarian emergencies, including heat waves, wildfires, floods, tropical storms, and hurricanes. These events are increasingly scale, frequency, and intensity. Climate change, due to the change in temperature, creates a suitable environment favorable to several pathogens known to cause diseases such as Cryptococcus neoformans and Vibrio bacteria. So these are just some names of the pathogens that are they like the heat and they also light the change in the temperature. Areas with weak health infrastructure, mostly in developing countries, will be the least able to cope without assistance to prepare and respond. So, what this is basically saying is that in times when there the severe storms and people end up getting hurt due to flood or whatever the situation may be, because there's a shortage in health infrastructure, or there's not enough beds, there's not enough equipment to facilitate the amount of patients or the amount of people in the country, it may cause an issue. It may also lead to death. And it can also occur in the extreme heat with the hotter temperatures. You might find a lot more people fainting, having heat strokes, having migraines, headaches. There might not be there might be enough of the necessary equipment to treat these ailments. And that's essentially the end of my presentation. And these are my references. Thank you.